discussing about semiconductor materials. Semiconductor materials are the backbone of electronic devices and circuits. So what is a semiconductor material? Probably all of you know about conductors and insulators. Now conductor is a material which, when you apply a voltage surge, it creates a generous flow of charge, like for example a copper. Copper is a metal and metals are conductors. Now insulator is a material that offers a very low level of conductivity when a voltage is applied. For example, mica. Now semiconductor material is in between this conductor and insulator. So it is a material that has conductivity level somewhere between the extremes of an insulator and a conductor. For example, germanium and silicon are these two materials which are semiconductors showing similar property. As you know, the resistivity of a material is inverse of conductivity. So if we compare the resistance levels of conductors, insulators and semiconductors, we see that the conductor has resistivity value which is the least among the three. That is, typically a copper, which is a conductor, has a conductivity maximum, so its resistivity value is around 10 to the power minus 6 ohm centimeter, whereas an insulator has a resistivity of 10 to the power 12 ohm centimeter, which is much more than conductor. But in semiconductor, like germanium and silicon, have resistivity values in between these two. For example, if we consider germanium semiconductor, it has resistivity value of 50 ohm centimeter, and silicon has resistivity value of 50 into 10 to the power 3 ohm centimeter. So you can see that semiconductor has resistivity in between conductor and insulator. Now if we consider these three, insulator, conductor and semiconductor, and see their energy band diagrams, then we find that the energy gap between the valence band and a conduction band in an insulator is very high. It is around 6 electron volt, as is seen here. So this energy gap means it is a forbidden band, and the electrons will have to acquire this much of energy to become conducting and enter a conduction band. But semiconductor does not have such a high forbidden energy gap, which is around 1 electron volt, as is seen here. So electrons can acquire that much of energy, which is 1 electron volt only, to jump from valence band to the conduction band in order to become conducting. And metals like copper, which are conductors, they have overlapping conduction band and valence band, and they have 0 electron volt. That is why they are so much conducting, because electrons can very easily shift between valence band and conduction band and take part in conduction. So semiconductor is a material that has conductivity level between the extremes of insulator and the conductor that we have seen. And why this is so? That is because the semiconductor, like germanium and silicon, they have some unique qualities which are due to their position in the periodic table and their atomic structure. These are group 4 elements. So the atoms of these materials, like germanium and silicon, they have a very different and definite pattern that is periodic in nature. That is, it continuously repeats itself, and one complete pattern is called a crystal, and the periodic arrangement of the atoms is a lattice. Now both germanium and silicon have 4 electrons in the outermost orbit, which are called valence electrons. Now in order to complete the structure of inert gas, they will always try to complete the 8 electrons in the outermost orbit. So in the pure germanium or silicon crystal, these 4 valence electrons will be bonded to 4 neighboring atoms as is shown in this diagram. So here, as you can see, if I consider a germanium atom, so it has 1, 2, 3, 4 electrons in the outermost orbit, which are called valence electrons. Similarly, silicon will also have 4 electrons in their outermost orbit. These are because they are group 4 materials. Now, they will be trying to complete the 8 electron structure in the, so that is why they will be sharing electrons with their neighboring atoms, as is seen here. If we consider a silicon atom, these 4 electrons in the outermost orbit, they are sharing electrons among themselves, so that the total number becomes 4 and 4, 8. So these atoms which are nearby, they are sharing these covalent bonds. So these covalent bonds are formed between neighboring atoms of silicon, and thereby they complete the structure of the inert gas having 8 electrons in the outermost orbit, so that they become stable. So these semiconductors, which are in the purest form, are known as intrinsic semiconductors. So in these intrinsic semiconductors, the free electrons are due to only natural causes like thermal energy or light energy, which impart extra energy to the electrons to become free, and thereby they get additional kinetic energy from these natural causes, and they break these covalent bonds. These covalent bonds, they will be breaking in order to become free. One electron will become free when it absorbs kinetic energy from either the surrounding or any light is falling on them. Now, an increase in temperature, which is naturally the reason for more conductivity in semiconductors. So this increase in temperature of a semiconductor results in increase in the number of free electrons in the material. So they become more and more conductive. So even though they may be not so conducting at a certain temperature, but if we increase the temperature, they will be absorbing more kinetic energy and will become more conducting. So the semiconductors like germanium and silicon, they have negative temperature coefficient, as the resistance will be decreasing with increasing temperature. This is a peculiar phenomenon that is seen in semiconductors, which is just opposite to your conductors like metal.